Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at sequences of numbers. So here we just have a string, a list of numbers. So x here gives us the index of it. So the first term we call it is 10, second term 14, third term is 18, and so on. So these sequences follow a predictable pattern. So what you can see here is that each time x is going up by 1, y is going up by 4. So this number 4, by which y is increasing each time, is called the gradient or the difference. So here the gradient or difference between each term is positive 4, and you can clearly see that y is going up by the same amount each time. So in this particular case, we say that the gradient or difference is constant. It doesn't change. Y is going up by the same amount each time. So when such a situation arises, we say the sequence is arithmetic. The sequence 10, 14, 18, 22, 26, 30, and so on is arithmetic sequence, and we also call it linear because if you were to plot each of these as a point, so plot the point 1, 10, 2, 14, 3, 18 in the Cartesian plane, they would all lie in a straight line. And it turns out that this happens whenever the gradient or first difference is constant. So of course we could follow on with this pattern, but it's often really useful in maths to have a formula, a rule, an equation from which we can figure out the y value if we know the x value. So when you have an arithmetic sequence or a linear relationship between x and y, the equation can always be written as y equals mx plus b. So here m and b are constants. It turns out m here is the gradient. So in this particular case, the gradient was 4. So I'm going to change m to 4. Now it turns out this b is called the y-intercept. It is the y value when x equals 0. So to find out that, we can just follow the pattern here. If we go down by 1, if x decreases by 1 so that we get to 0, y will decrease by 4. So the y value when x is 0 would be equal to 6. So the rule linking x and y is y equals 4x plus 6. In other words, to get the y value, you just take the x value, times it by 4 and add 6. 4 times 2 plus 6 is 14. 4 times 3 plus 6 is 18. Finding the rule for a linear relationship turns out is nice and easy. All right, let's look at this sequence here. So we have a sequence here, 1, 2, 5, 10, and so on. Here, x is again indexing. So the first term is 1, second term is 2, third term is 5, and so on. So here you might notice that the difference or gradient is not constant. We add 1 the first time, then we add 3, then we add 5, and so on. If we were to follow the pattern, the next number we'd add 7 to get 17, and then we'd add 9. So there's a clear pattern here, so we should be able to come up with a rule still that links x and y. It just won't be linear. So this here is called the first difference, the difference between each subsequent y value. Now if we look at the second difference, that's the difference of the differences. See this sequence, 1, 3, is going up by 2, and so on. So this sequence here has a common second difference. It has a non-constant first difference, which means a non-constant gradient. So it's not a linear sequence. But it turns out when you have a sequence in which the second difference is constant, it is a quadratic sequence. So for a quadratic sequence, our equation is going to be y equals something times x squared plus something times x plus something. So because we know there's an x squared term because of the constant second difference, what we're going to do is we're going to subtract x squared from each of these y values. So we're going to come up with another row here, which will be y minus x squared. So to do this, I go 1 minus 1 squared is 0. 2 minus 2 squared is negative 2. Then 5 minus 3 squared is negative 4, and so on. 10 minus 4 squared is negative 6, 17 minus 5 squared, and you can see that there is a clear pattern here. So this sequence here is linear, because if we just look at the sequence 0, -2, -4, and so on, we can see that each time x is increasing by 1, y is decreasing by 2. So what would be the formula of just this sequence here? Well, the y value, to get this value in green, what do you do to the x value? Well, the gradient here is -2, because each time x goes up by 1, y decreases by 2. So that's the number that goes here in place of m when you have a linear sequence. All right, so what's the number that goes here? It's the y value in x equals 0. So if I went 1 over, so x equals 0, this value here would be +2. So it's actually y equals -2x plus 2. Okay, that here gives me the rule for this sequence here. So for the quadratic sequence, it's simply going to be y equals 1x squared minus 2x plus 2. So that again is the rule that tells you how to get the y value from the x value. If you take the x value, square it, subtract 2 lots of it, plus 2, you get the y value. So 2 squared minus 2 times 2 plus 2 is that. 3 squared minus 2 times 3 plus 2 gives you 5, and so on. All right, let's now look at another type of sequence. So let's look at what is happening here with this sequence. So once again, the difference is non-constant. So the y value is increased by 21, then it's increased by 84, then it's increased by 336, and so on. You can see that the y value is getting big very, very quickly. Now the second difference isn't common either. So the second difference here, we added 63 to get from 21 to 84, then we added 252. The second difference is not constant. So, because the first difference is non-constant, it's not linear. The second difference is non-constant, it's not quadratic. This is a special type of sequence called a geometric sequence. See, what is happening here, instead of adding the same amount each time, we're multiplying by the same amount each time. So each time x increases by 1, I've actually multiplied y by 4. 7 times 4 is 28, times 4 is 112, times 4 is 448. So the value that goes in here would be 448 times 4, which is 1792. So let's come up with the formula for a geometric sequence. So what happened was we started here with y being 7. This next one is 7 times 4. Then, to get 112, we took our previous one, which was 7 times 4, and we times by 4 again. So that's 7 times 4 squared. Similarly, to get here, we went 7 times 4 times 4 times 4. We went 7 times 4 cubed. Hopefully you can see the rule here is that it's the first term times the common ratio to the power of 1 less than x. So we say here that 4 is the common ratio because each term is the previous term multiplied by 4. You're multiplying by 4 each time. That's the number that goes there. This was the first term and it's just x minus 1. And that helps us. We can figure out the value of any term. For example, rather than following on the pattern, we could easily figure out what is the y value when x equals 10. We simply go to our calculator, y equals 7 times 4 to the power of 10 minus 1, 1,835,008. So this is clearly not a linear sequence. Were I to plot these points, they actually wouldn't lie in a straight line. They'd sort of look like this, which is actually exponential. They get big really, really quickly. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.